Welcome to Module 11, Lesson 4. Our I can statement for this lesson reads, I can use multiplication and division to write fractions that are equivalent to a given fraction. So we're going to expand on what we were working on in the last lesson with equivalent fractions and continue to use our multiplication and division to find equivalent fractions. All right, so let's go ahead and complete our first question. Karen is mixing organic fertilizer for her garden. She needs to add 3/4 teaspoon of fertilizer to the water, but she only has a 1/8 teaspoon measuring spoon. How many times does Karen need to fill the 1/8 teaspoon measuring spoon? You want to know how many eighths will equal 3/4. Okay, so it's a little tricky. We need to find how many eighths are in 3/4. Write the two fractions in an equation. Okay, it already has one of our equations down here. Here it's asking us to find what's equal to 3/4. So while we haven't solved yet, we just need to put 3/4 here and our eighths here, because we're working in how many eighths will equal 3/4. Okay, we need to use multiplication to determine the relationship between the known denominators. We have the denominator 4 and the denominator 8. What do we know about those two denominators? 8 is 2 times greater than 4. So if we multiply our denominator 4 times 2, we'll get the denominator 8. Now, in order to have an equivalent fraction, we must also multiply the numerator by the same number we multiply the denominator. Remember, 2 halves is equal to 1 whole. We're multiplying this number by 1. We're changing the number of pieces, but not the size of the fraction. So 2 times our numerator 3 will give us 6/8. Okay, so what that means is we need 6/8 to equal 3/4. Karen needs to fill the 1/8 teaspoon measuring spoon 6 times to get to 6/8, right? Which will measure 3/4 of a teaspoon. Right, we're going to go ahead and complete our visual model to justify that, to prove it. So we have our 3/4 and then 6/8. I like to start in the same spot so that it gives me just a clearer visual model. There's 4, 5, and 6. All right, so let's go ahead and complete the next problem now. On this one, we're going to use division to find an equivalent fraction for 8/12. The first thing we need to do when using division is find the factors of 8. Now, remember, we're working with factors, okay? We need to find the two factors that multiply to the product and every set of those. So you can choose just to list your factors. I'm going to write mine in factor pairs. I like to always start with 1, 1 and 8. Then I can keep going. Is 2 a factor? 2 is a factor. 2 and 4. And 8 does not have any more factors or factor pairs. Okay, and then I'll do the same thing for 12. 1 and 12. Can do 2 and 6, 3 and 4. Okay, again, you could just have them listed out, right? You could have 1, 2, 4, 8, 1, 2, 3, 4, 6, 12 kind of fit. All right, so now we're going to look for what are the common factors of 8 and 12. Okay, pop up to vocabulary. A common factor is a factor of 2 or more numbers. You can use a common factor to divide the numerator and the denominator to find an equivalent fraction. So we have a couple of common factors here. Right? We have the common factor of 1, 2, and 4. Okay, so now we need to use a common factor other than 1. Right? If we divide this number by 1, the size of the pieces is not going to change because that number will remain the same digit. So 8/12 will remain 8/12. So we need to pick a different factor. Let's go ahead and divide by 2. So what I do to my numerator, I must do to the denominator as well. Again, remember I'm dividing by 2 halves here, which is equal to 1. If I divide 8 divided by 1, it will still give me 8. I'm not changing the size. I'm only changing the number of pieces, or the size of the pieces, not the size of the fraction. Okay, 8 divided by 2 is equal to 4. 12 divided by 2 is equal to 6. All right, on my visual model, I need to go ahead and break this apart to show 4/6. I'm going to use their lines to help guide me because 6 is a little tricky. I know that every 6 is equal to 2/12. So I'm just going to go every other line to help me. Okay, let's go ahead and shade our 8/12. And 4/6. All right, so we can see our visual models are proving to us that 8/12 is equivalent to 4/6. So our question asks us, why can two fractions have a different number and size of parts and still be equivalent fractions? Now, this is really important that we're basing these on fractions that are in equal size, right? If I had this long fraction that was 1/2 and then this little tiny fraction of 1/2, even though these are both equal to 1/2, the sizes aren't. So you can see that when we have a 1 whole that is equal, the number of parts are just the size of those pieces. So 8 of 12 pieces is equal to 4 of 6 pieces. So they're equivalent. All right, go ahead and complete the check understanding. Pause the video and press play when you're ready to check your work. Okay, let's go ahead and check your work. For number 1, they spend the same amount of time in the garden. I know this because 8/10 divided by 2 halves is equal to 4/5. So it's showing that that's an equivalent fraction. For number 2 and 3, you may have used different numbers than me. For number 1, I multiplied by 3/3. So I found my equivalent fraction to 1/4 was 3/12. Now, I could have even multiplied by a number like 100, right? 100 hundredths, and gotten this was equal to 100 400ths. And those fractions would still be equal as long as we are multiplying by a fraction equal to 1. All right, for 4/8, I want to make sure I have my factors. So 1 and 4, 2 and 2, 1 and 8, 2 and 4. Okay, so I had common factors of 4, 2, and 1. I just used 4 as my common factor and get 1/2. I could have also used 2. Maybe you used 2. Okay, 4/8 divided by 2 halves is equal to 2 fourths.